Hey guys, Mr. Backerberg here. In this video, we're going to take a look at the cosecant function. So as we're graphing out a cosecant function, so for example, if we had f of x equals the cosecant of x, what we want to remember is that cosecant is related to our sine function. So what we're going to do in this function is pretend that it says the sine of x, and we're going to do all of our normal sine graphing things, and then we're going to adjust our picture from there. So the first thing I want to do is make an x and y chart. Now this graph doesn't have any phase shifts or period changes, so we're going to start at 0 and we're going to end at 2 pi. Halfway between 0 and 2 pi is pi. Halfway between 0 and pi is pi over 2. And halfway between pi and 2 pi is 3 pi over 2. Now if I plug in 0, the sine of 0 is 0. If I plug in pi over 2, the sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and then the sine of 2 pi is 0. So I'm going to plot those out on a graph. So at 0, we're at 0. At pi over 2, we're up at 1. At pi, we're down at 0. 3 pi over 2, we're down at negative 1, and at 2 pi, we're back to 0. Now I'm going to graph this out as a dotted line because this isn't actually the graph that we want to take a look at in this example. We want to look at the cosecant. So what we have to remember is that the cosecant is the reciprocal of the sine, meaning that these y values are going to be flipped over. So where we have y values of 0, if we do the reciprocal of those, we'd really get 1 over 0. So that ends up being an undefined value for all of these. And when we have undefined values on our graph, those are going to show up as vertical asymptotes. So we've got a vertical asymptote at 0, we've got a vertical asymptote at pi, and we've got a vertical asymptote at 2 pi. Now this chunks our graph up into some U-shaped pieces, and what we're going to do with those is take them and flip them over. But we're still going to use the top of this wave and the bottom of this wave to help us out. So I need a U-shaped piece between my asymptotes that hits that pi over 2, 1 point, and then I need an upside down U-shaped between my last two asymptotes, hitting that point 3 pi over 2 and negative 1. Now as we're taking a look at this example, we've got the cosecant of 2x minus pi over 4. And just like we did on the last one, to graph this out, we're going to pretend that this says the sine, do all of our normal sine graphing things, and then make adjustments to the picture. So this one has a phase shift and a period change. So I'm going to find a new starting point by taking my stuff inside of the parentheses and setting that equal to 0. So the first thing I'm going to have to do is add that pi over 4 over to the other side. So I get 2x equals pi over 4. I'm going to have to divide the 2 over to the right-hand side. So I'm going to end up with x equals pi over 8. So as I'm starting to build my x and y chart, my first x value is going to be pi over 8. Now to find my ending point, we're going to take the stuff inside of the parentheses and set it equal to 2 pi. I have to add the pi over 4 over to the right-hand side, and when I do that, I should get 2x equals 9 pi over 4. But then I have to divide by 2, and when I do that, I should get an x value of 9 pi over 8. So that's going to be my last x value in here. Halfway in between pi over 8 and 9 pi over 8 is going to be 5 pi over 8. Halfway between pi over 8 and 5 pi over 8 is 3 pi over 8. And halfway between 5 pi over 8 and 9 pi over 8 is 7 pi over 8. Now I have to take these x values and start plugging them into my function. So first thing I want to do is plug in the pi over 8. Pi over 8 times 2 is pi over 4. Minus pi over 4 is 0, and the sine of 0 is 0. So at pi over 8, I'm at 0. I'm going to approximate that to be about right there. So then I plug in 3 pi over 8. 3 pi over 8 times 2 is 3 pi over 4. Minus pi over 4 is 2 pi over 4, but that reduces down to just pi over 2. And then the sine of pi over 2 is 1. Then if I plug in 5 pi over 8 times 2 is 5 pi over 4. Minus pi over 4 should just give me pi, and the sine of pi is 0. 7 pi over 8 times 2 is 7 pi over 4. Minus pi over 4 is 6 pi over 4, but that reduces down to 3 pi over 2. Sine of 3 pi over 2 is negative 1. And lastly, 9 pi over 8 times 2 is 9 pi over 4. Minus pi over 4 should end up giving us 2 pi, and the sine of 2 pi is 0. So we end up getting a picture that looks something like this. And again, I'm going to graph this out with a dotted line since this isn't really the graph that we want to take a look at. Now where we've got those zeros, remember when we flip them over, those become undefined values. So we have a vertical asymptote at pi over 8, at 5 pi over 8, and also at 9 pi over 8. Then I'm going to take these middle chunks of my graph and flip them over. So this one becomes a U shape between my first two asymptotes, and the second one becomes an upside down U shape between my last two asymptotes. That's going to be it for this video. Thanks for watching.